Okay, so good afternoon also from my part. Quick introduction. Hello, I'm Chris from Telraam. Telraam, we're a small spin-off from Transport Mobility Leuven, traffic-based consultancy and research group in Leuven, Belgium. With Telraam, we're doing traffic counts in a citizen science setting, and Telraam was a component of the Compare project. So as you can see, Compare is about measuring air quality in a citizen science setting, but we've also used traffic counts as a proxy basically for air quality estimates and allowing also to do some more correlations and so on. If you're curious about how we've deployed all these sensors and how that then I'm going to disappoint you. This is just a 10-minute section where I take a more overarching view on what you should take into account if you're working with sensors in a citizen science setting. More high level view, which is obviously stemming from the Telraam experiences, but also the other sensors that we've used in Compare. Compare is quite unique in that we have like a lot of sensors used, and there are some common denominators where we can draw some lessons from, which I want to share now in this next section of 10 minutes. So this shows the Telraam sensor that we've been using in Compare. So on the left side, you can actually see the Telraam sensor as before the Compare project, the one that we used when we started with the project. And on the right-hand side, the one that we used in the Compare project. You'll see that the one on the right looks much more flashy and the one on the left looks much more DIY. And there's the first lesson here, I think, for everybody that I want to jump onto is that designing sensors for use in citizen science does not per se have to be something very, very technical. Your key is to work with to make it usable for scientists. So I've distilled our project, which is now what 3.5 years in, just half a year to go, if I'm correctly. So I've distilled three key lessons for anybody who wants to work with sensors in a citizen science project, and that's the first one is design for ease. The second one, if you are a sensor or a tech provider, make yourself redundant, because if you're not redundant, you're going to be the bottleneck and you'll be flooded with questions, which you don't want. And the third one is trial. Trial a lot. Do not per se trial a tech, but trial your method and how you use the sensors in a citizen science setting. So the first part here, the first lesson, and I first have a slide where there are some consolidated lessons, but then how we did that in Compare. So I'm an engineer. I'm expecting that the audience is also full of engineers. We have a tendency to over-engineer as we're techies. We want to add this or that feature. Be aware that your citizen scientists are not waiting for that. There is a subgroup, a small subset of citizen scientists who are very techy and very nerdy and are just like us, but actually the majority isn't like that. The majority just wants to be involved, wants to count, and wants to have clear instructions. So that means that you need to make your sensor also align with that, and that has to be the core of your design idea, that you make it simple. As any citizen science project, Compare explicitly wanted to reach beyond the usual suspects, naming the 30, 40-year-old highly educated white males. We want to also reach beyond that. And then the above is a prerequisite. You cannot expect from, I don't know, elderly 70-year-old people to install complex Wi-Fi sensors, for example. That it has to be much more simpler. So again, those are key elements if you want to work with citizen science sensors. And be clear from the start what your sensor can and cannot do. That means answering the same questions many, many times. So you have to be clear that, for example, in the case of Telraam, you cannot count near collisions or something, or can it count how many cars are passing by or taking an intersection and a cross left and a turn right. No, just left and right. It cannot distinguish between steps or electric bikes. You have to make that clear from the beginning. Then your citizen scientists are also on board with the right mindset. Otherwise, they might be disappointed. So key lessons, the first key lesson is if you want to use sensors in citizen science activities, focus your development on UX UI, the user experience, make it simple. And to do that, you should not start from scratch. So you should start with a technology which is already actually proven and existing, and then tweak that tech to make it more user-friendly, not adding more features or something, or making a new detection script or whatever. No, just actually simplify. cut things so that's easier to use for non-techies. So what did we do in Compare? So again, my background is from Telegram, so I can talk a lot about the Telegram sensors, but we've used a lot, and we started all sensors from existing sensors. So the Telegram V1s, which we upgraded to the S2s, the Sodak air quality sensor, the One World were also existing. Sensor.community used to be Luftdaten, so which has been around for a long time. So you have to start with that, because if you're going to design your own sensor in a citizen science project, your whole project time will go to designing the sensor, and then you can maybe start with deploying them in a citizen science setting, and you actually need that time as well to do it properly. So start from something, and that's what we did. We've also tried and gone different approaches on sensor distribution. So we've heard workshops. So volunteers come to a workshop, you explain how the installation process go, distribute the sensors, and people go home to self-install. That's I think a very good, good approach to do that. You can go for mail delivery even. That's something that we've done as well. So volunteers hosted it on an online platform and made their candidacy clear, and then we sent the sensors via mail. I think a few other pilots have done the same thing. Something which I'll jump on later, so I call the super volunteer or community champion as an intermediate who can actually help as a bridge between the project team and the local volunteers. They are really big assets. That all being said, we have also done installation by the project team ourselves. Some sensors just require it, so be it. They are hosted by citizens, but some really need a technical installation. There's a downside to it, because then you're limiting resource. But yeah, sometimes you have to do that. There were changes made mostly on the how to install and how to like minor tweaks. For example, use different tape because it fell off the window. I mean, those are like small things which are almost trivial fixes, but they are very key in the user experience of the citizen scientist. So you have to focus on that part. The second part, the second lesson I want to focus on is the make yourself redundant. Again, this is something which may feel counterintuitive as a service provider or a developer. The thing is, if you are not redundant, then you're going to be the bottleneck from start to finish. So we designed Telegram already from the start for full self-installation. Because your citizen is a resource. And I mean, they are willing to spend time, they are willing to contribute. And if you enable them to do that, they're also very strong committed to the project. We have seen this in Compare, for example, where if a volunteer comes to a workshop, you explain how the sensor has to be installed, and people go home and install it themselves. The ownership of the sensor host is much higher than even if another volunteer comes in and installs it for them in their home. So it's really better to make to go for self-installation from a pragmatic point of view, that you don't have to spend time on that, but also from an engagement point of view, that you can have stronger commitment and stronger involvement of your citizen scientists. Jumping in here on this fourth bullet point, the community champions, or what I call super volunteers. I would say there's more or less 3 layers of involvement or contributors to a citizen science project, also with sensors. You've got technology providers, platform providers, us, let's say, in the case of Telegram. You've got the volunteers at the lowest level who are just hosting sensors, for example, who are just willing to spend some time but not be involved very much. But there's an intermediate level of people who are volunteers, but they strongly believe in the value of your project, and they're willing to spend more time. They want to help you. From a practical point of view, a super volunteer, we had one in Herzele who actually did do for free, spend time to do sensor installation with other people at home, because they were not comfortable doing it themselves. And the only thing that you have to do then as a project member is to facilitate and help this person to do this for you. So it's a different type of volunteer that you have to work in. Now, last but not least, on why you want to make yourself redundant, at least in our case, is that when Compare is finished, we want to continue. We want to continue with our citizen science project. And if you're needed to keep everything up in the air, then you're going to need extra funding. And again. So if you want to avoid going from project funding to funding, that it's going to be needed to keep your project in the air, make yourself redundant, get out of the loop. Once it's set up, and make sure that you're no longer needed. So actually the citizen science activity can continue without you. And that again points to the first lesson: make it simple, so that once installed, people can do their own thing, and that will save valuable research time from valuable and expensive PhDs in the project who have to do the actual scientific work, which Burcu, for example, explained in the previous section. So how did we do that? Lessons learned and compare. I think what we demonstrated is that self-installation is definitely possible. So do not underestimate the power of really committed volunteers, even if they're non-techies. So if you make it simple and you make clear instruction, people will be able to self-install. And as a fallback, you can work with super volunteers who can do some local troubleshooting, let's say. So I think that's really something which is an important insight also for us from the project, is that if you enable and you give the tools to locals to troubleshoot themselves and not make yourself a bottleneck, I mean, it's just a time saver for us, and it will allow you to scale much bigger. You'll be able to have many more sensors installed instead of having to troubleshoot every single one of them. And then the last lesson I want to highlight is that the trial to simplify. So you cannot get there from the first start. So like I said, you have to start from existing tech, and then your citizen science project should be phased where you can trial for specific deployment, and that should not focus on the sensor tech or on the sensor tech, yes, but on the how to use the sensor in the citizen science project. So the customer journey or the user journey, however you want to call it. But if in a project you still have to, I don't know, swap complete sensor or something, and you have to build everything around, and then you've lost another year and a half to make it right. The beautiful thing is, be ready for the unexpected. Weird stuff will happen. They're citizen scientists. You cannot control that. There might be oversubscription of volunteers. There might be undersubscription, but like more deepening. There might be people who want to be involved, who don't want to have a sensor, but want to be involved in the project in a different way. So you need to keep an open attitude and be, reactive. See how you can respond to how your project goes. I've been in citizen science now for 4 or 5 years, and you should always be ready for the unexpected and try to capitalize on what happens, and instead of trying to fix this in your project scheme. We have to do this, so we're gonna do this. Actually, you should create a condition. That's what I mentioned here. Create the conditions for engagement by maintaining an open attitude. So how did we do that in Compare? It was designed in the project itself. So we have actually 3 rounds in the project execution. There's a closed round where we work with sensors with friendly users in the project team itself. This allows you to get like the major problems out of the way of how the installation journey works. Then there's an open round, which is more selected or targeted from the project a team. And then there's a public round, which is your real test. I mean, did it work? And are you indeed redundant? Is it work? Are things happening automatically? Yes, no. And that's actually your real test. Now, I've been painting a nice picture here, and you might guess that Compare has been a super successful project without any issue. Obviously not. We also have had our technical issues. There, I think Burcu mentioned the PC meter as an example of a citizen science sensor for air quality. Very promising, very interesting. Theoretically, actually, a good citizen science sensor. Like, it was 3D printed and everything. But I think it's safe to conclude now, after a year or 2 years, that it's actually quite complex to install. You cannot ask this from non-techie citizens to install. So might be useful again for a niche of citizen scientists, but not like the wide audience. And then you have to adapt to that. And then another part that we encountered, but Lieve will jump on that, is that we had some connectivity issues. Yeah, you cannot avoid technical problems, so they will always pop up. And yeah, maintaining the open attitude. So in Bulgaria, for example, we didn't have for Telegram connectivity, and then we fell back to the old sensor and actually had more installations with the V1 than we expected. And an unexpected thing, for example, of maintaining the open attitude is that quite a few users were involved in providing validation data, ground truth data, which is super valuable for us as Telegram. So what does this mean? somebody installed a sensor and did a 50-minute manual count to see if it compared with reality yes no, which is super valuable for a tech provider as us to demonstrate. Look, this person has a sensor and has counted and it works. Wasn't really planned, but it's something that you can factor in as an example in a project by maintaining an open attitude and facilitating people to do so. So those are 3 high-level lessons. I mean, if you want to know more about the sensors, particularly at Telegram, you can reach out to me. But I think I'll leave the floor now to Lieve for more policy-related discussions.